Hello students, welcome to Talk on Civil Engineering. Through this video lecture, we are going to discuss the most important bits from your RCC subject. And these bits will obviously help you in competitive exams and also for quick revision of the subject. So here through this video lecture, I have covered 120 questions. So in these 120 questions, I have tried to cover the most important questions and most important topics from your RCC. Okay. Now let us start the class. The first question: the maximum area of tension reinforcement in beams shall not exceed. Answer: 4%. In these bits, I have given only the answer. I have not provided the options because options are not necessary if you remember the correct answer. So remember the correct answer, that is enough. Coming to question number 2. As per IS 456-2000, the pH value of water shall not be less than 6. Question number 3. The minimum number of main steel bars provided in RCC. For rectangular column, it is 4 bars. For circular columns, the minimum bars are 6. For octagonal columns, the minimum bars are 8. So the question may ask for a minimum bars for rectangular column or for circular or octagonal. So that's the reason I have provided all the requirements for different type of column. And also remember this point also, the spacing between main bars should not be more than 300 mm. Okay, so the spacing between the bars in the column, so this should not be more than 300 mm. Question number 4. The weight of a foundation is assumed as 10% of column load. The diameter of longitudinal bars of a column should never be less than 12 mm. So in the column, whatever the diameter of bar that you are using, it should be equal to 12 or more than 12. Question number 6. Thickened part of a flat slab over its supporting column is technically known as drop panel. So here I have provided diagram of a drop panel. So here try to know what is flat slab also. So flat slabs are the slab which is rested directly over the column. Question number 7. An RCC beam not provided with shear reinforcement may develop cracks in its bottom inclined roughly to the horizontal at 45 degree, or it is also called as diagonal cracking. Next question. The effective span of a simply supported slab is least of the center to center distance of a support, clear span plus effective depth. Span plus effective depth or the center to center of support. The least of these two. The least of these two will be your effective span, remember. Question number 9. In a beam, the local bond stress SB is equal to. So the local bond stress, how you can calculate, or what is the equation for a local bond stress? So that is equal to shear force divided by lever arm into total perimeter of the reinforcement. shear force divided by lever arm into total perimeter of the reinforcement. Question number 10. The tensile strength of concrete as per IS 456 is given by 0.7 under root FCK. 0.7 under root FCK. Question number 11. The split tensile strength of concrete as per IS 456, it is 2p under root 2p divided by pi dl. So for split tensile strength, we will be calculating the split tensile strength using 2p pi dl. Here p is the load applied on the cylinder and d is the diameter of the cylinder and L is the length of the cylinder. Question number 12. If D and N, or if effective depth and the neutral axis are the effective depth and the neutral axis respectively of a singly reinforced beam, the lever arm of the beam is, so you know the lever arm of the beam will be D minus N by 3, or this can be also written as D minus XA by 3, right? Question number 13. Design of a two-way slab simply supported on edges and having no provision to prevent the corners from lifting is made by Rankine-Grashof formula. So using Rankine-Grashof formula, or this Rankine-Grashof provided coefficients for two-way slabs. For two-way slabs that the corners prevent from lifting. So no provision to prevent the corners from lifting, coefficients of movement coefficients are provided by this Rankine-Grashof formula, so that we are going to use for the design of two-way slab. Question number 14. The percentage of minimum reinforcement of the reinforcement of the gross cross-sectional area in slabs is. So this minimum tension reinforcement depends on the type of steel in slabs. So if it is mild steel, the minimum is 0.15% of gross sectional area, and if it is HYSD, the minimum is 0.12% of gross cross-sectional area. So in the case, if steel type is not mentioned, so what you have to do? You have to take the maximum of these two. So the maximum is 0.15, right? So this will be the correct answer in case the steel type is not mentioned. Remember. Question number 15. A T-beam behaves as a rectangular beam of a width equal to its flange if its neutral axis remains within the flange. If the neutral axis remains within the flange, that means, so here you have a T-beam. If the neutral axis remains within the flange, this is your neutral axis, then this will be designed as a rectangular beam. Question number 16. Side face reinforcement is provided if the depth of the member exceeds 750 mm. Question number 17. Maximum spacing of main reinforcement in slabs should not exceed 3D or 300 mm. So the maximum spacing is 3D, 3 times of effective depth, or 300 mm, whichever is less. So from this you have to take the least value. Question number 18. Minimum reinforcement in beams as per IS 456 is. So the minimum reinforcement is AST minimum is equal to 0.85 by Fy into BD. So try to remember this formula, 0.85 Fy BD. Okay, and maximum percentage is 4%. We have already discussed this maximum. Question number 19. Maximum spacing of distribution reinforcement in slabs. So initially we have seen for main reinforcement. So here this is distribution reinforcement. So for distribution reinforcement, it is 5 times of effective depth or 450 mm, whichever is the minimum. For main reinforcement, 3 times of effective depth and 300 mm. Question number 20. Maximum flexural reinforcement in columns. So in columns, the maximum flexural reinforcement that needs to be provided is, sorry, here I have given 4%, so it is not 4%, it is 6%. So 6% is a maximum reinforcement in columns, whereas 4% for beams. 4% is beams, not for columns. Remember. 21. Question number 21. For stiffness control of beams and slabs, the basic value of L by D ratio up to 10 meters span. So for cantilevers, it is 7 L by D ratios. So these are the L by D ratios. So for cantilever, the L by D ratio is 7. For simply supported, 20. For continuous or fixed beams, so the L by D ratio is 26. And remember, these values are up to 10 meters only. So he may ask you what is up to what distance these values are valid. Like that also he may ask the question. Question number 22. For spans exceeding 10 meter, the basic values of deflection control is multiplied by. So they are multiplied by 10 by span. For example, for a cantilever, the value is 7, right? So for this 7, you have to multiply 10 by span if the span is more than 10 meters. Question number 23. A slab set to two-way slab. A slab said to be two-way slab if Ly by Lx ratio is greater than or equal to 2. So if Ly by Lx ratio, that is the larger span by the lesser span, larger span by the lesser span is greater than or equal to 2, so it is called as two-way slabs. Or another way of finding what type of slab is that based on the bending. So if the bending happens on both the sides, it is also called as two-way slab. Question number 24. For stiffness control of two-way slabs, the basic value of L by D ratios using MS. So this is for two-way slabs. Initially we have seen for one-way slab or for beams. For two-way slabs, you will have a different set of values, and these values for L by D overall depth. So initially we have seen those values for L by effective depth. So L by D, this effective depth values will be for one-way slabs or beams, and L by overall depth for two-way slabs. Remember, this is the difference. And for two-way slabs, for simply supported two-way slab, the L by D ratio will be 35, and for continuous or fixed, the L by D value is 40. And these values for mild steel, remember, these values for mild steel. Question number 25. for stiffness control of two-way slabs, the basic value of L by D ratios using HYSD bars. So the value is for simply supported, it is 28. For continuous or fixed, it is 32. So usually you will get this value for mild steel values if you multiply the mild steel values L by D ratio with 0.8. Okay. So if you multiply 0.8 with the mild steel values, you will get this. So if you remember only these values, that mild steel values, it is enough. If you want to get the HYSD values, for this you have to multiply 0.8. So for simply supported 35 into 0.8, you will get the value for HYSD. For 40 into 0.8, you will get the value for HYSD L by D ratios. Let us go to question number 26. The same question, for HYSD steel, the basic stiffness control values given in IS 456-2000 are multiplied by 0.8. Question number 27. The stiffness control values provided in IS 456 for two-way slabs are valid for spans up to 3.5 meters, load not exceeding 3 kilonewton per meter square. So this is also important. So initial values that we have discussed for two-way slabs, those are valid for spans up to 3.5 meters and load not exceeding or not loads within 3 kilonewton per meter square. In case if this is exceeding, you have to take the values which are given for one-way slabs. Question number 28. As per IS 456, the bending moment on both directions of two-way slabs is calculated using, for movement about x direction is equal to alpha x w lx square, movement about y direction is equal to alpha y w lx square. So remember, in both the formulas you will be using lx, that is shorter span. In both you are using lx itself, that is shorter span. You may get confused by seeing in options. He will, in the options, for my he will provide ly only. So you will see that you will find that for my it is reasonable for providing ly. So you may choose that option, but that will be wrong option, right? So for my also you will be using lx itself. Remember. Question number 29. The width of middle strip and edge strip of two-way slab as per IS 456. So the middle strip is 3/4 and the edge strip is 1/8. So this is your middle strip. The middle strip is 3/4 of span and the edge strip is 1/8 of span, and this is also 1/8 of L. Similarly, on other direction also, these are divided into middle strip and edge strip. So this is 1/8, this is 3/4, and this is 1/8. Question number 30. The designed main reinforcement with respect to side of two-way slab is distributed in middle strip. So whatever the design reinforcement is there, so the designed main reinforcement is provided in middle strip of two-way slab. Question number 31. In simply supported two-way slab, 50% of the bars may be terminated within a distance of 0.1 L, 0.1 of span. The total torsional reinforcement provided at corners of two-way slab is 3/4 of maximum main reinforcement. So the area of torsional reinforcement will be 3/4 of the maximum steel. Question number 33. The torsional reinforcement is not required if the slab having continuity on both directions. Question number 34. In continuous slab, the bottom reinforcement bars at continuous edge should be extended to 0.25 L. So at continuous edge, the bars are extended to 0.25 L, and if it is at discontinuous edge, the bars are extended to 0.15 L. 0.15 L at discontinuous edge, 0.25 L at continuous edge. Question number 35. In continuous slab, the top reinforcement at continuous edge is provided for negative movement. In continuous slabs, you will get negative movements and positive movements. For positive movements, you will be providing the main bars at bottom, center, bottom, middle span, and for negative movement, you will be providing reinforcement top at support. Question number 36. In slabs having thickness D, the maximum size of aggregate should be 1/4 of the thickness or 1/4 of the capital D. Question number 37. Modulus of elasticity of concrete as per IS 456 is calculated using 5000 under root FCK. Question number 38. The effective or long-term modulus of elasticity of concrete is given by EC divided by 1 plus creep coefficient. EC divided by 1 plus creep coefficient, where EC is equal to 5000 under root FCK. So we can write this as 5000 under root FCK 1 plus theta. Question number 39. Young's modulus of steel is constant, which is equal to 2 into 10 to the power of 5 Newton per mm square. Whereas for concrete, it is non-constant value. It is not constant. Question number 40. The minimum grade of concrete recommended by IS 456 for RCC structures, that is M20. M20 is the minimum grade of concrete for RCC. Question number 41. The code book used for design loads. For dead load, you are going to use IS 875 Part 1. For live loads, IS 875 Part 2. For wind loads, IS 875 Part 3. For snow loads, IS 875 Part 4. And for special loads and load combinations, IS 875 Part 5. So remember these part names. Part 1 is for dead load, Part 2 for live load, Part 3 for wind load, Part 4 for snow loads, and Part 5 for load combinations. Question number 42. The criteria for earthquake resistant design of structure is provided in IS 1893-2002. IS 1893-2002 is for earthquake resistance designing. Question number 43. The design aids for reinforced concrete to IS 456-2000 are provided in SP 16-1980. SP 16-1980 provides the design aids for RCC, and SP 34-1987. SP 34-1987, it is the handbook on concrete reinforcement and detailing. Question number 44. In heavily reinforced members, the size of course aggregate is restricted to 5 mm less than the minimum clear spacing between bars or minimum cover to reinforcement. So whatever is the minimum of these two, that will be your answer. Whichever is small, that will be the answer. Okay. So the minimum 5 mm less than the minimum clear span. Clear span means between the bars. Between the bars, this is your clear span, and this is your minimum cover. Okay. So 5 mm less than this and 5 mm less than this will be your the maximum size of course aggregate. Question number 45. The target strength of concrete is determined using equation FCK plus 1.65 of standard deviation. This is the target strength of concrete. Question number 46. The compressive strength of concrete cylinder approximately equal to 80% of cube strength. So the cylinder strength will be approximately equal to 80% of cube strength. That means the cylinder strength is less than the cube strength. Question number 47. Compared to 150 mm cube compressive strength, 100 mm cube will have more strength. Remember, lesser the cube area, more will be the strength. Okay, because you know the strength or the stress is equal to P by A. So if E reduces, this sigma or strength will increases. Question number 48. The maximum stress in concrete under bending reaches at a strain of 0.002. I hope you have understood this question. The maximum stress in concrete under bending reaches at a strain of, so you will get confused between 0.002 and 0.0035. Okay, so here he asked that what is the maximum, where the maximum stress is reached. So if you remember the stress diagram, so it will be something like this, right? And it will get constant. So here this is the maximum stress. So it will reach us at 0.002, and this is at failure, that is 0.0035. Okay, and this question may ask in other way also, that is maximum compressive strain. Maximum compressive strain in concrete in axial compression is 0.002. So in axial compression, the maximum strain will be 0.002. The axial compression in this means it is a columns. That means he may ask in what is the maximum compression strain in columns. So in the columns, the maximum compressive strain is 0.002. Question number 49. The strain at failure or at outermost fiber of concrete is considered as 0.0035. Or this question may ask in another way, that the maximum strain in concrete at the outermost compression fiber in bending is 0.0035. Question number 50. The stress strain curve of concrete is parabolic up to 0.002. Up to 0.002 strain, you will have the parabolic variation. And try to remember this also, the stress strain curve is assumed to be rectangular in strain range of 0.002 to 0.0035. So remember this diagram. Okay, So remember this diagram. So here this is your strain is 0.002 and here you are having a strain of 0.0035 and this is your FCK, and here you will have, so this is a characteristic strength, this is your structural strength. So structural strength will be FCK divided by factor of safety, that is 1.5, and again you have another curve. So this is your design strength. So design strength will be FC, this FC, again we have to divide this with 1.5. So FCK divided by 1.5 and again 1.5. So that means it will comes around 0.45 of FCK and this value comes around 0.65 of FCK. Let us see the question number 51. As per IS 456, the tensile strength of concrete is ignored. And also remember this assumption also. Plane sections normal to the axis remain plane even after bending. So it is asked many times. That's the reason I have provided this statement also. Try to look at all the assumptions once. Those are important. As per limit state method, the design strength of concrete is considered as 0.67 FCK divided by 1.5. So already we have discussed this. So the design strength is 0.67 under root FCK. This 0.67 FCK is considered as the structural strength. Structural strength. So the structural strength divided by factor of safety, you will get the design strength of concrete. Okay, so here I have provided 0.67 FCK is the structural compressive strength and FCK is characteristic compressive strength. Question number 53. As per limit state method, the design strength of reinforcement shall be 0.87 Fy. 0.87 Fy is the design strength of steel. Question number 54. The maximum strain in the tension reinforcement in the section at failure shall not be less than Fy divided by 1.15 ES plus 0.002. Fy divided by 1.15 is the partial safety factor for steel into ES plus 0.005, or in another way this equation can be written as 0.85. So simply Fy divided by 1.15 you will get 0.87. So 0.87 Fy divided by ES plus 0.002. So this is the maximum strain in the tension reinforcement and it should not be less than this value. Question number 55. As per IS 456 for Fe 415 steel, the yield strength is taken corresponding to a strain of 0.004. So in the absence of data, so you will be taking the yield strength corresponding to 0.004 strain for Fe 415 steel, and for Fe 500 we are going to take the stress at corresponding to 0.0045 strain. Okay, in another way you can take the yield strength based on proof stress also. So proof stress is taken as yield strength. So what is the proof stress? Proof stress, the stress at, so this is at the stress at 0.2% of strain. Stress at 0.2% of strain by offset method. Okay, so offset method means for a curve you need to draw a parallel line at 0.2% of strain. So wherever this curve is meeting, so that will be your proof stress. Okay. Now coming to question number 56. As carbon content increases in steel, strength increases, ductility decreases. So as carbon content increases, strength increases, but the ductility decreases. Question number 57. Ultimate creep strain is more if load is applied at earlier age of concrete. Ultimate creep coefficients. So try to remember this ultimate creep coefficient values also provided in IS 456. For 7 days, it is 2.2. For 28 days, 1.6. For 1 year, it is 1.1. So for early age of concrete, you will have more creep coefficient. As the age of concrete is increasing, you will the creep coefficient will also decreases. Question number 58. The characteristic load is defined as the load with dash probability of not exceeding, that is 95% of probability not exceeding in the entire life of the structure. That will be your characteristic load, 95% of not exceeding. Whereas the characteristic strength of material is the strength below which not more than 5% of test results expected to fall. Not more than 5% of test results expected to fall. That will be your characteristic strength of material. Let us see the question number 59. The compressive strength result variation of 3 cubes should not exceed plus or minus 15%. So the 3 cubes strength should not vary plus or minus 50%. If it is exceeding this plus or minus 50%, you should not consider that cube strength. Question number 60. As per IS 456, the minimum grade of concrete to be used in mild and extreme exposure condition is M20 and M40. So M20 is for mild condition, mild exposure condition, and M40 is for extreme exposure condition. Okay,